Welcome back to our module on linear equations. This is lesson 3 and it is called Linear Equations in X. And our goal for today we will learn how to find all the solutions to a linear equation in X. The question that I want you to be thinking about is, what are the building blocks of an equation? So in the previous lesson, we learned about the difference between linear expressions and nonlinear expressions. And now we're going to take that information that we learned and we're going to apply it when we're looking at linear equations, because that's the 8th grade standard, is knowing how to identify and graph a linear equation. So the things to know that we need to talk about with the beginning of this lesson is, where are the linear expressions? Okay, where are they? Basically, a linear expression is an expression, or not expression, an expression of a linear equation is each part of the equation. So what we are looking at here for this specific question is, this right here is considered a linear expression. And then this right here is considered a linear expression. And just like we learned in yesterday's lesson, they are set apart by an equal sign. And we know that they are linear because the variable has an exponent of 1. And so we know that's what makes them linear. And then what you have to do is you have to identify those two expressions that are set off by an equal sign that is telling you an expression equals an expression is giving you an equation. And because this variable has an exponent of 1, you know it is a linear expression. So remember that an equation is made up of expressions. So we actually have two linear expressions sitting right here. 4 plus 15x is a linear expression, and 49 is a linear expression. And the reason why 49 is considered a linear expression in this case is because it is equal to this. All right, so what is a linear equation in X? A linear equation in X is an expression containing, a variable raised to the power of 1 or 0 that equals another expression. Okay, so that's what I would say is a linear equation in X. And the reason why it's in X is because, again, our variable that we chose is X. Okay, so now we're going to try to decide if the following the following equations are linear equations based on what we just said. So we have 4 plus 15x. So remember, 4 is your constant, 15 is your coefficient, and x is your variable. And supposedly the solution would be 49. So what happens with this is that you have to figure out what number would make this math sentence true. And so what I would like you to try to figure out if this is the correct solution is, I would like you to try the numbers 2 and the numbers 3. Now when I say try the numbers, what I mean is, does x equal 2 or does x equal 3? That's what we're trying to figure out, okay? So if we're going to do that, then I would like us to give it a try, and here's how you give it a try. You just plug it in. So we're going to try 2 first and say 4 plus 15 times 2 equals 49. Okay, that's the first one we're going to try. So we know that we need to do multiplication before we add. So 15 times 2 is actually 30, right? Plus 4 equals 49. And then we know that 30 plus 4 is actually 34, right? And that does not equal 49. So we would say when x equals 2, that is no solution. Okay, so x cannot equal 2. All right, so now let's try if x equals 3. Okay, So if we're doing x equals 3, we're going to do the exact same steps, except I ran out of room, so I'm going to put it down here. And I'm going to say 4 plus 15 times 3 equals 49. So multiplication before adding, so 15 times 3 is actually 45, plus 4, and then we have 45 plus 4 equals 49, and now we see that 49 equals 49, so we would say yes, x equals 3. Okay? So that's how you're going to determine if this is actually a linear equation in x. If the solution balances, then it is a linear equation in x because you have one value that x can be that makes the solution true. All right, so now let's try the next one. So this time it says to try 5 and to try 1. So we're going to say, does x equal 5? Question mark. Does x equal 1? Question mark. Okay, so now let's take a look at it and try it. And it says that we're supposed to take 8 times 5 minus 19 is equal to negative 4 minus 7 times 5. Okay, now remember that both of these are linear expressions in x because your exponent is 1, your exponent is 1. So we should be able to go. Okay, 8 times 5 is actually 40 minus 19 equals, and then we have here, if we do the rule for subtraction, is that subtracting is the same as adding the opposite. So let's multiply these two here first, and we get 35, and then it says subtract it. So we're going to do 40 minus 19, so that would become a 3, that would be a 10. So this is 1, and that's 2, so that would be 21 equals, and now we have adding the opposite. So this is actually negative 35 plus negative 4, so that's actually negative 39. So I would say no, no solution. So this one is no solution when x equals 5. Okay, now let's try the other one and see what we get. So it says to try it as 1, so we have 8 times 1 minus 19 is equal to negative 4 minus 7 times 1. So now we have 8 times 1 equals 8 minus 19 equals negative 4 minus 7 times 1 is 7. Then we remember that subtraction is the same as adding the opposite. So we'll go ahead and do that. And now we have subtraction is the same as adding the opposite. So negative 19 negatives combined with 8 positives gives me negative 11 equals, and then we have negative 4 plus negative 7. So there's 7 negatives and 4 negatives, which gives us negative 11. And so it does equal negative 11 does equal negative 11. So we would say yes, x equals 1. Okay? So again, we found another linear equation in x when x equals 1. Okay? So this is not so bad, right? You just have to like plug in the values that I give you and then decide if it's a linear equation in x. And we would say yes, as long as x is 1. Yes, as long as x is 3. Okay? So that's pretty simple. I have a couple more that I would like you to try. They're getting a little bit trickier. So this time we want you to try 5/4 as a possible value for x and 2 as a possible value for x. So I'm going to help you set it up, but then I want you to do the math by yourself. So again, is it possible that x could equal 5/4? And is it possible that x could equal 2? That's what you need to set up for that one. And then the last one that I want you to try is I would like you to see if x could be equal to 6 or x could be equal to 3. And I would like you to try both of those problems by yourself because I want to make sure that you have confidence with knowing how to do this. Okay? So remember your rules of order of operations. Don't let this over here really panic you because remember it's just distributive property, but when you already know the value of x, you do what's inside first and then multiply it by your coefficient of 3. Substitute in your values and see what you get. Same thing down here. Substitute your values in and see what you get. Follow the order of operations. Okay? So, what we have learned is that a linear equation in x is true when you can find a value of x that makes the solution true. So this one, the solution, or x cannot be 2 because it's no solution. X has to be 3 because the solution is 49. This one, 5 cannot be the solution because they're not equal. 1 is the solution because they are equal, being negative 11. Okay, so going back to our goal, today we will learn how to find all the solutions for a linear equation in x, which is what we did. The question that I asked you to think about in this lesson is, what are the building blocks of an equation? The building blocks of every equation are the two expressions and an equal sign. One expression has to equal the other, and that's what makes it a linear equation. Okay? All right, kiddos, that's all I have for you today. Talk to you soon. Bye!